Berlin, the German capital, is a 21st century metropolis in the heart of Europe. It has a long history, famous historic buildings and unique architectural monuments from various eras through to contemporary architecture. All these modern buildings and projects consist of quality-controlled construction materials with selected characteristics, extreme resistance and high demands on environmental compatibility, on static equilibrium and structural safety. The company testing Bluhm and Feuerherdt is based in this European city. In its modern production facilities, Testing, one of the most renowned German providers of complete construction material testing laboratories, manufactures testing machines, premium laboratory devices, as well as stainless steel laboratory equipment of the highest quality. Our product portfolio contains around 3,500 different, mainly standardized products. For new and further developments, we have experienced mechanical engineers, electricians, hydraulic specialists and concrete experts at our disposal. Here, a new Blaine device is being developed in the engineering department. We currently produce the widest range of Blaine devices worldwide, from simple hand-operated devices to computer-controlled automatic models. The manual Blaine device, according to EN 196, is used exclusively to determine the grinding fineness of cement and should only be used for this purpose. To determine the grinding fineness of cement, its specific surface area must be established from the air permeability of an accurately defined compacted cement bed. This is done by observing the time taken for a fixed quantity of air to flow through the cement bed. This time is then a measure for the specific surface area, which is indicated in square centimetres per gram. The laboratory, testing equipment and test material must have a temperature of between 18 and 22 degrees Celsius, as well as a maximum relative humidity of 65%. Inspect the visible condition of a delivered consignment immediately. Any damage which occurred during transport or a shortfall in quantity must be logged without delay and submitted to us by fax or email. Use the delivery note to verify that the consignment is complete. It must include a manual Blaine device with thermometer and aspirator bulb with valve, a permeability measuring cell with perforated disc and plunger, a suction and filling syringe with a bottle of manometer liquid and an alternative filling funnel, a container with light grease, a packet of filter paper discs, plugging rod, a small brush, thermometer and seal plug, operating instructions and an application DVD. Not included in the delivery scope, but necessary tools and aids include a timer, various reference substances, a measuring spoon or spatula, an analytical balance accurate to 1/1000th of a gram, a fine brush, a bottle with a screw lid, an electronic vernier caliper accurate to 0.1 millimeters or a standard micrometer gauge and depth gauge. Irrespective of the type, the Blaine device must first be set up and aligned on a stable, level and vibration-free surface. The device is now ready for operation. First, the supplied manometer liquid is sucked in with the aid of the suction and filler syringe in order to fill the U-tube to the lowest etched line. The U-tube must be clean and dry before filling. The stopcock must be closed and the manometer liquid filled in up to the etched filling line. The procedure must be carried out carefully as the gauge only adjusts slowly. The manometer liquid has almost reached the lowest etched line. Should the filling level be exceeded, excess liquid must be carefully sucked out using the suction syringe. The etched lines on the U-tube have the following designations: oil filling height, number 4, stopping point, number 3, starting point, number 2, top or suction point, the highest etched line, number 1. Other important components of the Blaine device are the permeability measuring cell, the stopcock, the U-shaped tube, the aspirator bulb, and the connection support for the measuring cell. Finally, the thermometer is attached to the device. Determining the apparatus constant K. As the Blaine method is a comparative test between a known and an unknown material, a reference sample with a known specific surface area as a comparison is required in order to determine the apparatus constant K. As supplied by the manufacturer, the device is, as a rule, not calibrated. Calibration must be carried out in which the apparatus constant K is determined for the reference substances. This is required later in order to calculate the Blaine value. If the apparatus constants have already been determined, testing can begin immediately. First, the volume of the permeability cell is determined. The inner diameter G is measured with a micrometer gauge or, deviating from the standard, with a vernier caliper accurate to 0.01 mm at 6 different points and the mean value calculated. Then the perforated disc is placed on the lower edge of the cell. 2 new filter paper discs are pressed onto the perforated disc with a clean, dry rod until they are lying flat. Now, using the depth gauge, measure the inner dimensions J of the cell at 6 different points. The measurement should be accurate to 0.01 mm to give an average value. Also, measure and determine the length of plunger F at 6 points. It's now possible to mathematically calculate the powder bed volume V from equation 1, in which J is the inner dimension of the cell, F the plunger length, and G the cell diameter. In the sample calculation, the powder bed volume is 1.935 cubic centimeters. The calculation of the powder bed sample weight, M0, the reference substance, must be carried out according to equation 2. The porosity of the powder bed and the density is adopted by the reference substance. In the sample calculation, a sample weight of 2.564 grams is calculated. Density and porosity were adopted by the reference substance. Here, the adopted values are again marked in red in the equation. The appropriate apparatus constant K must be determined separately for each reference substance. The reference substance for determining the apparatus constant is shaken for at least 2 minutes in a closed bottle in order to dissolve any agglomerates. The bottle is then left to stand for 2 minutes. Finally, the powder bed is stirred with a clean, dry rod in order to evenly distribute the fine particles. Lightly grease the cell from the outside in order to guarantee an airtight fit in the U-tube. The perforated disc is placed on the bottom of the cell. Lay a filter paper disc flat on the perforated disc. Then, using the analytical balance, the calculated sample weight can be carried out to 0.001 grams. Different weighing tools can be used for this purpose. The powder bed is levelled by lightly tapping the cell wall. A second filter paper is placed on the levelled surface area. Gently but firmly press the plunger onto the powder bed until the lower face of the cup is in contact with the upper edge of the measuring cell. Then slowly withdraw the plunger approximately 5 mm, rotate it through 90 degrees and press it onto the powder bed again. Slowly withdraw the plunger from the compacted powder bed without disturbing it. Insert the cell in the conical socket at the top of the manometer. Close the top of the cylinder with a suitable plug. Open the stopcock and suck in the manometer liquid with the aspiration bulb. Subsequently, with the arrow buttons, it can be drawn in and corrected upwards or downwards. Raise the level of the manometer liquid to the highest etched line marked number 1. Close the stopcock and remove the plug from the top of the cylinder. Start the timer as the liquid reaches the second etched line. At the stopping point mark 3, stop the timer and make a note of the time accurate to 0.2 seconds. 3 time and temperature measurements are carried out on 3 samples. For each sample, a mean value is established and the temperatures are precisely determined to 1 degree Celsius. The apparatus constant for samples 1, 2 and 3 are calculated according to equation 3. Here, S equals the specific surface area, ρ equals the density of reference standard sand, T equals flow time, eta equals air viscosity, and E equals porosity. In the sample calculation for sample 1, the apparatus constant K was determined at 19.47 to 2 places behind the decimal point for a reference substance of 2,800 square centimetres per gram and a porosity of 0.5. The mean value was established from the apparatus constants of the 3 samples. This is the apparatus constant required later for the appropriate reference substance. Calibration or recalibration is carried out for first use, after 1,000 tests, for a different type of filter paper, for another type of manometer liquid, for new perforated discs, for a new manometer tube, and in case of systematic deviations of the secondary reference cement. The apparatus constant is not transferable to other devices, not even to the same models. Determining the specific surface area of cement. Procedure. The specific surface area, the Blaine value, is to be tested on a random cement sample. A sufficient quantity of the cement to be tested must be filled into a bottle with a screw top. It must be shaken vigorously for 2 minutes in order to dissolve any agglomerates. The sample is then left to stand for 2 minutes. Subsequently, the cement is carefully stirred with a clean, dry rod in order to evenly distribute the fine particles. To prepare the cement bed, place the perforated disc on the lower edge of the cell and press it with a rod. A filter paper disc is laid flat on it and also pressed with a rod. Now the required cement bed mass, M1, can be calculated. The calculation takes place first with an adopted porosity of 0.5, the value of the density, ρ, of the cement, and the volume, V, of the cement bed. If the values are not known, they must be determined beforehand. This is done in the same way as described for determining the apparatus constant. The cement mass M1, calculated according to equation 2 for the cement bed to be prepared, is accurately weighed out to 0.001 grams and filled into the cell. The powder bed is levelled by lightly tapping the cell wall. A second filter paper is placed on the levelled surface area. Carefully press the plunger onto the powder bed until the underside of the collar touches the cap of the cell. Slowly withdraw the plunger, approximately 5 mm, rotate it through 90 degrees and press it onto the powder bed again. Slowly withdraw the plunger from the compacted powder bed without disturbing it. Caution: if the plunger falls through without any pressure, the sample weight is incorrect. The porosity must be altered until the compaction condition is correct. The same applies to a plunger which can't be completely pressed down to the stop. Repeat the test with altered porosity and a new sample until the conditions are correct. If the cement bed has been correctly compacted, the outer lightly greased tapered surface area of the cell is inserted into the tapered opening of the U-tube. The cell is hermetically sealed with a plastic plug. Open the stopcock in order to permit the suction process of the manometer liquid with the aspirator bulb. Suck in the test liquid to the level of the upper first etched line. Close the stopcock. This is no longer necessary for newer devices which have special aspirator bulbs. Remove the sealing plug from the cell in order to enable the flow of air through the cement bed. At the starting point, the second etched line, initiate the test procedure with the timer. At the stopping point, the third etched line, stop the measuring process and the timer and make a note of the measurement result accurate to 0.2 seconds. Register the test temperature to 1 degree Celsius. Repeat the test run and note the results. Remove the cell, close the stopcock and seal with a protective plug. Remove the cement bed. Clean the cell with a soft brush. A new cement bed is produced with a second sample, and the flow times are also tested twice. A mean value is established from the two flow times and the two test temperatures from sample 1. The same applies to sample 2. The specific surface area S of the cement can now be calculated according to equation 4. In this case, K is the apparatus constant, which has a similar Blaine value as the tested cement. E is the porosity of the cement bed. Rho, the density of the cement. Eta, the mean value of the two test temperatures. And T, the mean value of the two flow times. In the sample calculation, a specific surface area of 2,827 square centimetres per gram is determined for sample 1. The specific surface area S of the tested cement is now the mean value of S1 of sample 1 and S2 of sample 2. The value is rounded to 10 square centimetres per gram. Alkalis are released when mixing cement and water. Immediately remove any wet or dry cement which comes into contact with the skin. If cement gets into your eyes, wash them thoroughly with clean water and seek medical attention immediately. Protective clothing, rubber gloves and glasses should be worn. If the device has to be shipped, repaired or disposed of, the manometer liquid must be sucked out with a syringe. Do not shake or pour it out. The device may be returned to the manufacturer for repairs or calibration. This video clip shows the use of the Blaine device produced by the testing company in Berlin in accordance with EN Standard 196 Part 6 from 2010 for the visual clarification of the test and calibration process. The video does not replace current test standards, the guidelines of authorized personnel, or the official operating instructions of the Blaine device. National safety regulations must also be observed. The shown sample calculations are fictitious and should not be adopted. All values must be determined for the first time by the user and on an individual basis.